Okay, we start by saving the return address onto the stack and adjusting the stack pointer. We're going to move to loading the format string for the user to enter the Fibonacci index they desire. We run printf. We come down to take the user input. So this is the scan index format string. And then we load the user input variable into the x1 register. The scan index loaded into x0 register. User input variable loaded into the x1 register. And then we branch to scanf. We're going to put input of 6 as was suggested and hit enter. Moves us to the next line. We're going to now move to show the user entered Fibonacci index. So we're going to load the format string for show index into x0 register. We're going to load the user input variable into the x2 register. Then we're going to load the data from the address that's stored in the x2 register into the x1 register. Sorry, that's happening right now. Then we branch to printf. We should see the output. There we go. You entered Fibonacci sequence 6, as we did. We are now going to calculate the Fibonacci index or Fibonacci value for index 6 using dynamic programming. First, we load the user input variable into register x1. Then we're going to load the data from register address at x1 into the register at x0. Now we're going to branch to Fibonacci dynamic. There we go. We're in Fibonacci dynamic. We are going to, again, save the return address onto the stack and adjust the pointer. Now we're going to compare the index that we entered and brought with us into this function with 0. If it's equal to 0, then we're going to branch to done. It's not, so we compare the index value that we brought with us to 1. If it is, then we branch to done. It's not. So we move the index value from the x0 register to the x4 register. Here I'm using W registers since the front half was originally having problems before. Now we're going to use x3 as our loop counter, w3 as our loop counter, and initialize it to 1. There we go, we've done that. And we're going to use x2 to keep track of our fib n minus 2 and initialize it to 0. We're going to use x1 to keep track of our fib n minus 1 and initialize it to 1, since those are the correct values. Now we're going to use x0 to hold our fib n, our current fib value, and initialize it to 0. Now we compare the loop counter with the current index value, the one that I entered. So we're comparing w4 with w3. We end the loop if they're equal by branching to the end of the function. That is done. They're not, so we compute fib n equals fib n minus 1 plus fib n minus 2. That's using the add function, adding x1 and x2 registers and saving the result into the x0 register. We then move x1 into x2. That's fib n minus 1 into fib n minus 2. Obviously makes sense. And then we're moving fib n to fib n minus 1. So just iterating. Now we're going to increment the loop counter. So we're adding 1 into W3, storing it in W3. Now branch to the beginning of the loop. Here we are again. And we're going to continue this process. So we compare the loop counter and the loop if they're done. If the index value is the same as the loop counter. And then we are, again, computing the new fib n, moving the values, and moving fib n to fib n minus 1. Increment the counter one more time. Now we're branched to the beginning of the loop. We compare current index value with the loop counter we're running, see if they're the same. Branch to done if they are. They're not. Compute fib n again. Moving, incrementing. Now we branch to the beginning of the loop. Again, compare. Let's see if they're equal. They are not. And so we are not branching to done. And now we're computing the new fib n, moving into x, or adding it, x1 and x2, putting them into x0, the result. And then we shuffle again the fib values. Now increment the loop counter one more time. Branch to the beginning of the loop. Compare the loop counter with the index value. Branch if they're done. If they're the same, they're not. So we compute the new fib value into x0. Move x1 to x2. Move x0 to x1. Increment the loop counter again. Branch to the beginning of the loop. Now we're comparing the index value that we brought with us, 6, with the loop counter, which is now 6. And we're going to end the loop if they're equal by branching to the end of the function. That is done. There we go. Now we're going to retrieve the return address from the stack that we saved at the beginning. And now we're going to return to that. And we're saving it into the link register, LR register. And now we're going to return to that location. There we go. Just where we left off in main. Now we're going to show the dynamic Fibonacci value of the user entered index. So we're moving that value that we've just brought back with us from Fibonacci from x0 to x2. We're going to put the format show dynamic format string into x0. We're going to put the user input address, the address for the user input variable into x3. We're going to load that data from that address into x1. So now we've got our 3 variables in a row that we need to run our correct format string. And we're going to branch to printf. We're going to see it come in the target console on the bottom right. There we go. Using dynamic programming, fib index 6 is a value of 8. Now we're going to do the same with the recursive function. So again, address of the user input variable goes into register x1. We're going to load the data from the address at x1 into x0. Now we're going to branch to Fibonacci recursive. There we go. Now we're in the Fibonacci recursive function. We're going to, again, save the return address onto the stack and adjust the pointer. We are also going to save the index value onto the stack and adjust the pointer. That's coming from x0 that we brought with us. And now we're comparing the index value that we just stored. We're comparing that with 0. If it's 0, then we're going to branch to the base case. It's not. Now we're going to compare it with 1, because if it's 1, we're also going to branch to the base case. It's not. So it's a recursive case. We're branching to recursion case. Here we go. We're in recursion case. So retrieving the current index value from the stack into an ARM register. Here we go. We're popping it off the stack. And we're not popping it, sorry. We're just grabbing the value, the data that's at that point on the stack pointer, and putting it into the x3 register. Now we're going to decrement that index value by 1, and we're going to store it into x0. There you go. Subtracting 1 from x3, storing it in x0. Putting the result in x0. Sorry, not storing. Now we recursively call this fib recursive function with the decremented index. Again, we pop up to the top. Not pop, but we move up to the top and we save that return address that we just had onto the stack, adjust the stack pointer, save the index value at the appropriate address onto the stack, and adjust the pointer. Now we're comparing the index value with 0. Is it 0? If it is, base case. No, it's not. If it's 1, base case. Is it? No, it's not. So we go to recursion case, and we, again, retrieve the current index value and put it in x3, and decrement the index value by 1, and putting it in x0, and again branch to the top. So we're starting to load the stack with all our index values that we want and keep dropping them down by one, doing it in a recursion style. Again, return address onto the stack, adjusting pointer, index value onto the stack, adjusting pointer, compare with 0, is it, base case if it is, no it's not, compare with 1, base case if it is, no it's not, recursion case. Retrieve that current index value, decrement it by 1, put it in index 0, branch to fib recursive. Again, store save return address, and save the index value onto the stack, and compare index value with 0. Is it 0 if it is base case? No, it's not. If it's 1, base case. It's not. Recursion case. Retrieve that current index value, decrement the index value by 1, put it in index 0, and branch to recursive. Again, save return address and adjust pointer, save index value, adjust pointer, compare it with 0. Is it, go to base case? No, it's not. Is it 1, base case? No, it's not. So we branch to recursion case. Now we retrieve the current index value, put it in x3, and then we decrement that index value, putting it in x0. Then we recursively, again, call Fibonacci recursive. Now we're saving the return address and adjusting onto the stack and adjusting the pointer, doing the same with the index value, comparing it with 0. If it's 0, go to the base case. It's not. Is it 1? Go to the base case if it is. It is. Okay, so we're in the base case. So that means, well, it's 1. We just saw that. Now we're storing that if it's base case, then the value of that fib value is equal to its index value. So we're storing the index value that we had at the stack pointer. We're storing it in at x0 that we just brought with us. We're storing it onto the stack pointer and adjusting the stack pointer because that's going to be the new fib value for that index value. Then we're branching to the end of the function and recursive. Now we're loading the fib value of the current index from the stack into x0, and we're going to adjust the stack pointer to the original address from before this function was actually called. So we're adding onto the current stack pointer to get us in the right place we want to be, and we're saving that, putting that result into stack pointer location. Now we're retrieving the return address from the stack and adjusting as well, loading it into the link register, and then we're going to return to that location. Boom, it brings us right after the fib recursive call. Now we're going to save the result from that recursive call. So we're storing what's in x0 onto the stack pointer and adjusting. Now we're going to retrieve that current index value from the stack into x0, loading it into x0. Now we're going to decrement the index value by 2 and pass it and put that into x0. Again, recursively call the function again with the decremented index. Here we go, we're at the top. We're saving the return address onto the stack, adjusting the pointer, saving the index value onto the stack and adjusting the pointer, compare it with 0. If it's 0, branch to base case. It is, because we got down to 0 recursively. Now we're storing because it's the base case, that means the fib value is equal to its index value, so we're storing that index value onto the stack pointer and adjusting. Now we branch to the end of the function. Here we are. We're going to load the index value from the stack onto x0. We're going to add to adjust that stack pointer again to get to the original address before this part of the function was called. Now we're going to retrieve the return address from the stack, put it into the link register, and adjust as we do, adjust stack pointers as we do, and we're going to return to where we came from. There we go. We saw we just came from that location. the second recursive call in this part of the function. Now we're going to load the previously saved results from the stack and put it into x1. And we're going to add those two results together because this is how actually the fib values computed. So x0 plus x1 goes into x0, and then we're going to save that computed Fibonacci value. So this is where the actual computation is happening, other than the base values, of course. So we're going to store the value from x0 onto the stack pointer and adjust as we do. And I commented out this branch end recursive. It obviously just takes us right to end recursive anyways, but the logic is there. It makes sense. I should have just left it. So we retrieve the current fib value of the current index from x0, put on the stack pointer, adjust the stack pointer again. So we're skipping over that beat because over that value because we don't want to mess around with it. We want to retrieve the address from the stack pointer onto the link register and adjust again. Now we return again. Now we're back to that front call, that first recursive call inside that part of the function. We're going to save the result of the recursive call at the save the results. So that's the fib result onto the stack pointer and adjust. And we're going to retrieve the current index value from the stack into x0 and adjust. We're going to decrement the index value by 2, pass it, so that's x0 minus 2 here into x0. Recursively call again. Now we're going to save the return address, so we're on our way up through the stack. And we're going to save the return address to the appropriate, save the return address onto the stack, adjust. Then we're going to save the index value, the current index value onto the stack pointer and adjust. We're going to compare index value with 0. If it's 0, we're going to go to base case. It isn't. Is it 1? Compare it with 1. If it is, go to base case. It is. We're going on our way back up, like I said. So we store that fib value because it's base case. We store the fib value is its index value, so we store that onto the stack pointer and adjust, and we branch to end recursive. Then we retrieve that fib value from the current index and put it into x0. We're going to adjust the stack pointer. Again, like I said, adjusting the stack pointer by that amount at 16 and adding it into the current spot of the current stack pointer. We're going to retrieve the return address from the stack into the link register and adjust. And return to that location. Here we are in the second part of our Fibonacci recursive in this part of the function. Then we're going to retrieve the previously saved result into x1 and adjust from the stack. We're going to add the two results again. This is how it's computed: x0, x1 together into x0. We're going to save that fib value onto the stack pointer and adjust. Now we're going to retrieve the fib value of that index into x0 and adjust the stack pointer to its original address before it was called, like I keep saying. So adjust by this much, the stack pointer by this much, and put it into the current stack pointer. Now we're going to retrieve that's to skip over the value. We're going to retrieve the return address from the stack and adjust, and then return to that location. Here we are again. Now we're storing, we're saving the result onto the stack pointer and adjusting. We're retrieving the current index value from the stack and adjusting. We're decrementing that value by 2 x0, we're going to minus the value of 2 and store it in 2, put it in 2, and recursively call. So we're on our way back up through. We'll just carry on with this. We save the return address onto the stack and adjust. Save the index value onto the stack and adjust. Compare it with 0. If it's 0, go to base case. It's not. Compare with 1. If it is, go to base case. It's not. Okay, we're back on our way up. Now we go to recursion case. Now we're going to retrieve the current index value from the stack pointer into x3. We're not adjusting because we're starting to suck those values out of the stack pointer. Then we're going to decrement by 1, decrement the index value by 1, and put it and pass it into x0, and call Fibonacci recursive again. We're going to store the link register to where we just came from, and onto the stack pointer, and adjust. And we're going to store the index value, save the index value onto the stack, and adjust. Now we're going to compare it with 0. If it's 0, go to base case. If it's 1, go to base case. It is. Now, now we're storing. Because the fib value is equal to the index value, we're storing the index value, which is in x0. We're storing it on the stack pointer and adjusting. Now we're branching to the end of recursive. Now we retrieve the fib sequence value of the current index, and we load it into x0 and adjust the stack pointer. Now we're just going to straight up adjust the stack pointer to skip over that value. As mentioned, we're putting the adjusted stack pointer into stack pointer, the result of the add. Then we're going to retrieve the return address from the stack and adjust, retrieving it into the link register. Then we're going to return to that location. Then we're going to store the result of the recursive call onto the appropriate address on the stack. So that's just storing from x0 onto the stack pointer and adjusting the stack pointer. We're going to retrieve the current index value from the stack. So we're taking the value from stack pointer onto x0 and adjusting. We're going to decrement the index value by 2. So that's x0 minus the value of 2. Put past that into x0 again. Recursively call again. So we save the return address into the stack and adjust. Save the index value into the stack and adjust. Compare it with 0. If it's 0, go to base case. It is 0. Now, if it's base case, then the fib value is equal to its index value. So we store the index value, that's x0, onto the stack pointer and adjust. We branch to end recursive. Now we retrieve the fib sequence value from the current index. We load it from the stack pointer into x0, adjust the stack pointer. Now we're just going to straight up adjust the stack pointer again, storing that into stack pointer. And we retrieve the return address from the stack, putting it into link register and adjust the stack pointer because we took the value, and returning to whence we came. Now we're retrieving the previously saved result from the stack pointer into x1, adjusting stack pointer, add those two results together, add x0 to x1 and store that in x0. And we're going to save the result of that from x0 onto the stack pointer and adjust stack pointer. Okay, we're retrieving the fib value from stack pointer into x0, adjust stack pointer. Adjusting stack pointer again to skip over that. Now we retrieve the return address from the stack into the link register and adjust the stack pointer. Now we're going to return to that address at link register. Now we retrieve the previously saved result from the stack into x1. So stack value from stack pointer goes into x1, adjust the stack pointer, add the two results together again. x0 added with x1, both of those are put into x0. Computed result goes into x0. Now we're going to save that fib index value at the current index onto the stack and adjust the stack, and we're down to the end recursive part again. We load the fib sequence value of the current index from the stack into x0. So loading from that value from the stack pointer into x0 and adjusting the stack pointer. Again, adjusting the stack pointer to skip over it. Retrieving the return address from the stack pointer into the link register and adjusting the stack pointer, returning to that address. We're going to save the result from the recursive call return at the appropriate address onto the stack. So we're storing the value at x0 onto the stack pointer and adjusting the stack pointer. Retrieve the current index value from the stack pointer into x0, adjusting stack pointer. We're going to decrement the index value x0 by 2 and put it into x0 again. We're going to recursively call the function again with the decremented index. So we save the return address at the appropriate stack, save the return address onto the stack and adjust. Save the index value onto the stack and adjust. Compare the index value with 0. If it is, go to base case. It's not. Compare it with 1. If it is, go to base case. It's not. Go to recursion case. Now we're going to retrieve the current index value from the stack into register x3, not adjusting the stack. Decrementing that index value by 1 and putting it into x0. That's subtracting 1 from x3 and putting it into x0. And we're going to recursively call the function again. We're going to save that return address on the stack and adjust. We're going to save the index value onto the stack and adjust. And we're going to compare that index value with 0. If it is, go to base case. It's not. Compare it with 1. If it is, go to base case. It's not. We go to recursion case. We're going to retrieve the current index value from the stack into x3. We're going to decrement that index value by 1 and put it into x0. We're going to recursively call. Now we save the return address onto the stack and adjust. Save the index value onto the stack and adjust. Compare with 0. If it is, go to base case. It's not. Compare with 1. If it is, go to base case. It is base case. Now because it's base case, the value is equal to the index value. So we store that index value on the stack pointer and adjust, and we branch to end recursive. Now, we're retrieving the index value from the current index, retrieving the fib value of the current index from the stack into x0. So we're pulling data from loading from stack pointer into x0, adjusting. We're going to adjust that stack pointer again to get over it, and we're going to retrieve the return address from the stack into the link register and adjust and go to that, return to that location. Now we're saving the result from the recursive call onto the stack and adjusting the stack, retrieve the current index value from the stack and adjust. We're going to decrement that index value by 2 and pass it into x0 and recursively call the function again. Storing that link register, the return address into the stack pointer and adjusting, saving the index value onto the stack and adjusting. Compare that index value with 0. If it is, go to base case. It is. Base case, the value is the same as the index value, so we're storing the index value onto the stack pointer and adjusting. We branch to end recursive. We retrieve the fib value of this current index from stack pointer into x0 and adjust the stack pointer. Again, adjust the stack pointer and save that into the stack pointer to hop over. And we retrieve the return address from the stack into the link register, because we're going to go to that location and adjust the stack and return to link register address. We retrieve the previously saved result from the stack into x1 and adjust the stack. We're going to add the two results together, x0 added with x1, store that in x0, put that in x0, pass it to x0. And we're going to save that computed value onto the stack and adjust the stack. And now we're retrieving the current fib value and into x0 and adjusting the stack pointer. Adjust the stack pointer again to bypass that value or move over it, whatever you want to call it. We're going to retrieve the return address from the stack into the link register and adjust the stack pointer. And we're going to return to that address. Okay. Now we are actually on our way up. Save the result of the recursive call, return the result from x0, save it onto the stack, and adjust. Load the current index value from the stack into x0 and adjust. Now we decrement the index value in x0 by 2 and pass it into x0 again. We recursively call the function again with the decremented index. Now save the return address onto the stack and adjust. Save the index value from x0 onto the stack and adjust. Compare the index value with 0. If it's 0, go to base case. It's not. Compare the index value with 1. If it is, go to base case. It is. So that means the fib value is equal to its index value. So we're storing that x0 value, index value, onto the stack and adjusting branch to end recursive. Now we retrieve that fib value, loading it into x0. We want to adjust the stack pointer to its original address and put that into stack pointer. Now we're going to retrieve the return address from the stack into link register and adjust the stack pointer, return from that to that address. Now we retrieve the previously saved result from the stack pointer into x1 and adjust the stack pointer, add the two results together, x0 added with x1, result passed into x0. Now we're going to save that computed fib value, storing from x0 onto the stack pointer and adjust the stack pointer. Now we retrieve the fib value, loading it from the stack pointer into x0 and adjust the stack pointer, adjusting the stack pointer, skip over, retrieving the return address from the stack pointer into the link register, adjust the stack, return to that address. Okay, maybe now. Actually on the way up. Now we retrieve the previously saved result from the stack into the ARM register, loading the result into x1 and adjusting the stack pointer. We add those two results together, x0 added with x1, pass that into x0. Save the computed fib value at the index, at this current index, onto the stack pointer, and so storing from x0 onto the stack pointer and adjust the stack pointer. Now we retrieve that fib value, loading it from stack pointer onto x0, adjust stack pointer. Now we're adjusting the stack pointer to skip over. Now we're retrieving the return address from the stack pointer into link register and adjust the stack pointer. Return to that location that's currently in link register. We save the result of the recursive call from x0, put it on the stack pointer, adjust the stack pointer. Now we load the current index value from the stack into x0. Now we decrement that index value by 2 and put that result put the decremented index value into x1, into x0, sorry, branch to fib recursive. We save the return address on the stack and adjust. Save the index value on the stack and adjust. Compare the index value with 0. If it's 0, go to base case. It's not. Compare the index value with 1. If it is, go to base case. It's not. Go to recursion case. Recursion case. Retrieve the current index value from the stack into an x3. Don't adjust stack. Decrement the index value by 1. Pass it into the ARM register. Decrementing the index value from x3 by 1, putting into x0. Recursively call. So saving the return address from the appropriate address onto the stack. Saving the link register address onto the stack and adjusting. Saving the index value onto the stack and adjusting. Comparing that index value with 0. If it's 0, go to base case. It's not. Compare it with 1. If it is, go to base case. It's not. Go to recursion case. Retrieving the current index value from the stack into x3. Don't adjust the stack. Decrement the index value by 1. Pass it into x0, so x3 minus 1. into x0 and recursively call. Now we save that return address into the stack and adjust. Save the index value into the stack and adjust. Compare the index value with 0. If it's 0, go to base case. It's not. Compare it with 1. If it is, go to base case. It's not. Recursion case. Retrieve the current index value from the stack. Don't adjust the stack. Decrement the index value by 1. Put the result in x0. Recursively call. Save the return address at the into the stack and adjust. Save the index value into the stack and adjust. Compare it with 0. If it's 0, go to base case. It's not. Compare it with 1. If it is, go to base case. It is. So that means the fib value is equal to the index value. We're going to store that onto the stack and adjust. And we're going to branch to the end of the function. Now retrieve that fib value from stack pointer into x0 and adjust the stack pointer. Adjust that stack pointer again. Retrieve the return address from the stack and adjust the stack. Now return to that location in the link register. Save the result of the call, storing from x0 onto the stack pointer and adjust the stack pointer. Retrieve the current index value from the stack pointer into x0 and adjust the stack pointer. Decrement the index value by 2. And pass it into x0. So x0 minus 2 into x0. Recursively call the function again with the decremented index. Now we're going to save the return address from save the return address onto the stack and adjust. We're going to save the index value onto the stack and adjust. We're going to compare it to 0. If it's 0, go to base case. It is. So that means that the fib value is equal to its index value. We're going to store that index value from x0 onto the stack pointer and adjust stack pointer. Branch to end recursive. Now we're going to load, retrieve the current fib value from the stack into x0, adjust the stack. We're going to adjust the stack to skip over. We're going to retrieve the return address from the stack and adjust the stack pointer. We're going to go to that return address. Now we're going to retrieve the saved result from the stack pointer into x1 and adjust stack pointer. We're going to add the two results together, x0 added with x1 into x0. We're going to save the fib value from x0 onto the stack pointer, adjust the stack pointer. We're going to retrieve the fib value from the stack pointer and adjust the stack pointer, retrieving it into x0. We're going to adjust that stack pointer again to skip over, storing that in the stack pointer. We're going to retrieve the return address from the stack and adjust the stack pointer. We're going to go to that return address. We're going to save the result for the recursive call at the appropriate address. Storing the result from the recursive call from x0 onto the stack pointer and adjust the stack pointer. We're going to retrieve the current index value from the stack into x0 and adjust the stack pointer. We're going to decrement the index value x0 by 2 and put that into x0. We're going to recursively call the function again and save the return address onto the stack and adjust. Save the index value onto the stack and adjust. Compare that index value with 0. If it's 0, go to base case. It's not. Compare it with 1. If it is, go to base case. It is. Now the fib value is equal to the index value, so store the index value from x0 onto the stack pointer and adjust the stack pointer, branch to end recursive. We're going to retrieve that fib value from the stack into x0 and adjust the stack. Adjust that stack to skip over the value, that fib value. We're going to retrieve the return address from the stack and adjust, and we're going to return to that address. Now we're retrieving the previously saved result from the stack into x1, adjust the stack. Now we're going to add those two results together, x0 added with x1, store or pass that into x0. Now we're going to save the that computed fib value from x0 onto the stack pointer and adjust the stack pointer. We're going to retrieve the fib value again from the stack into x0 and adjust the stack pointer. Now we're going to adjust the stack pointer to go over. We're going to retrieve that return address from stack pointer, adjust stack pointer, return to that location. And we're going to save the result from x0 onto the stack pointer and adjust the stack pointer. We're going to retrieve the current index value from the stack into x0 and adjust the stack pointer. We're going to decrement the index value by 2, x0 minus x2 is passed into x0. We're going to recursively call the function again with the decremented index. Now we save the return address from the link register onto the stack and adjust. Save the index value onto the stack and adjust. Compare with 0. If it is, go to base case. It's not. Compare with 1. If it is, go to base case. It's not. Branch to recursion case. Now we're going to retrieve the current index value from the stack into the ARM register x3. We're not going to adjust the stack. Decrement the index value by 1, so x3 minus 1. Pass that into x0. Recursively call the function with the decremented index again. Now we're going to save the return address at the appropriate. Save the return address onto the stack and adjust. Save the index value onto the stack and adjust. Compare with 0. If it is, go to base case. It's not. Compare with 1. If it is, go to base case. It is. Now we're going to, because it's base case, the fib value is the index value, so we're storing the index value onto the stack pointer and adjusting the stack pointer, branching down recursive. Retrieve the fib value from the stack into x0 and adjust. We're going to adjust that stack, adjusting stack pointer. We're going to adjust the stack pointer again. We're going to retrieve the return address from the stack and adjust the stack, and we're going to go to that return address. Now we're going to save the result from the recursive call at the appropriate address onto the stack. So storing from x0 onto the stack pointer, adjust the stack. We're going to retrieve the current index value from the stack into x0 and adjust the stack pointer. We're going to decrement that index value by 2 and store it into x0. We're going to recursively call the function again with the decremented index. Now we're going to save the return address onto the stack and adjust. Save the index value onto the stack and adjust. Compare the index value with 0. If it is, go to base case. It is. Okay, so that means that the fib value is equal to its index value. So we're storing the index value onto the stack pointer and adjusting the stack pointer, branching down recursive. We're going to retrieve the fib value from the stack pointer and adjust the stack pointer. We're going to adjust that stack pointer to its original address and store and pass that into the stack pointer. We're going to retrieve the return address from the stack and adjust the stack. Now we're going to return to that return address. Maybe we're getting there. We're going to retrieve the previously saved result from the stack into x1 and adjust the stack pointer. We're going to add those two results together. x0 added with x1. Pass that into x0. We're going to save the fib value we just computed from x0 onto the stack pointer and adjust the stack pointer. We're going to retrieve the fib value from the stack pointer into x0, adjust the stack pointer, adjust the stack pointer again to skip over, and retrieve the return address from the stack. Pointer into the link register and adjust the stack pointer. We're going to go to that address. Now we retrieve the previously saved result from the stack into we retrieve the previous fib value result from the stack into x1, and we adjust the stack pointer. We're going to add those two results together. x0 added with x1 goes into x0. We're going to save that computed fib value from x0 onto the stack pointer and adjust the stack pointer. We're going to retrieve that fib value and put it from the stack pointer into x0 and adjust the stack pointer. We're going to adjust the stack pointer to skip over it. We're going to retrieve the return address from the stack pointer and adjust the stack pointer. We're going to return to that address. We're going to retrieve the previously saved results from the stack pointer into x1 and adjust the stack pointer. We're going to add those two results together, x0 out of the x1, pass that into x0. We're going to save the computed result we just did from x0 onto the stack pointer and adjust the stack pointer. We're going to retrieve that fib value from the stack pointer into x0 and adjust the stack pointer. We're going to adjust the stack pointer to skip over. We're going to retrieve the return address from the stack pointer into the link register and adjust the stack pointer. We're going to return to that address in the link register. We're finally back in main. Now, wow. We're going to, now we're moving to show the recursive fib value that we just did all of that work for the current user entered index. So the current value that we just came back with is in x0. We're going to move the value, that fib value that we just calculated recursively, from x0 into x2, because that's where we need it for this string format. We're going to load into x0 now that we don't need x0 anymore. We're going to load the format show recursive string format into x0. We're going to load our user address of our user input variable into x3. We're going to load the data that is at that address that's stored in x3 into x1. Now we have all our stuff ready, and now we can print the recursive fib value finally, and there it is. Using recursive function, Fibonacci value of 6 is 8. Now we can just generate this fib sequence. I can imagine all this is going to be so much faster. We're going to load the address of the Fibonacci array into x0. We're going to load the address of that user input into x2. I'm taking the data that's in the address at x2 and I'm loading into w1. I had some issues with x's and w's. I believe it's resolved anyways, but my code still stands the way it is and still functions great. Then we're going to branch into fib sequence with those values in the registers we just did. Now we're in the fib sequence. So we're going to save the return address onto the stack and adjust the stack. We're going to move that index value that we brought with us in W1. We're going to move it to W8. We're going to compare the index value with 0. If it is, we're going to compare it with compare the index value with 0. If it's not equal to 0, we're going to go branch to 1. So we branch to 1, and now we're going to compare that index value with 1. If it's not equal to 1, we're going to go to sequence. So we're in sequence because our index value is 6. Now we're going to use x9 as a loop counter. We're going to initialize the 1. So we're just putting a value of 1 into the x9 register. We're going to use x2 to keep track of our fib n minus 2. We'll initialize it to 0. So we move a 0 into the x2 register. We place the value at the address of x0 into x2. And then we're going to use x1 to keep track of our fib n minus 1. We're going to initialize that to 1. Now we're placing the we're storing the x1 value, which is 1, into at the we're x0, the address of the, I forgot how this even worked. We're the x0 is the address of the array, and we're gonna index over 8 bytes, and then we're gonna store. That's where we're gonna store the second value of the sequence from x1. That's storing from x1 into the address at x0, adjusted for the index of 8. Now we're going to use x3 to hold our fib n. We're going to initialize that to 0. So storing the value of 0 into x3 register. Now we're starting the beginning of the loop. We're going to compare the loop counter with the max index value, and we're going to end the loop if they're equal. They're not. So we're computing fib n, which is x3, using x1 plus x2, storing that index, passing it into x3. Now we're gonna shift our fibs again. So we're moving fib n, moving the data from x1 into x2, moving the data from x3 fib n to fib n minus 1 into x1. Now we increment that loop counter, that's x9, by 1. We're going to add 1 to the loop counter and pass that into x9. And we're going to store that value from x3 into the array that's at address x0, and we're going to use that loop counter at x9 multiplied by our amount we shift for that index value, which is left shift left 3, and then we're going to branch to the beginning of the loop. Now we compare the loop counter with the max index value, compare x8 with x9. We're going to branch to the end of the loop if they're equal. They aren't. So we're computing fib again. x1 plus x2 goes into x3. Now move x1 to x2, move x3 to x1, increment that counter x9 by 1, storing, passing it into x9. Now we're going to store that fib value from x3 into the array at address x0, indexed by x9 times left shift left 3, x9 being our index value, our current loop counter, sorry. Time left shift left 3, branch to the beginning of the loop. Compare our loop counter x9 with our max index value x8. End the loop if they're equal. They're not. So we compute the fib value of x3, which is x1 plus x2. Then we move x1 to x2. Again, this is like the iterating part. And move the fib n to n minus 1. That's x3 into the x1. Now we're going to increment that loop counter by 1. X9 plus 1 goes into x9. Now we're going to store this x3, this computed fib value. We're going to store it into the array at x0, which is the loop counter x9 times the space or the size of each piece in the in the array LSL3. Now we're going to branch to the beginning of the loop. We compare x9 again with x8. That's our max loop counter with our max index value. If they're equal, we go down. They're not. Compute fib n again. That's x3 is going to equal x1 plus x2. Now we're going to move that x1 into x2. We're going to move that x3 into x1. We're going to increment that loop counter. X9 plus 1 goes into x9. We're going to store that computed fib value from x3 into the array at x0, but at position loop counter x9 times amount to shift LSL3. Now we're going to branch to the beginning of the loop. Compare our loop counter with our max index value. Compare x9 with x8. If they're equal, go to done. They're not. We're getting there. Compute fib value, so x3 is going to equal x1 plus x2. Move the x1 to x2, move the x3 to x1. We're going to increment that loop counter x9 by 1 and pass it into x9. We're going to store that recently computed fib value from x3 into the array at x0, but move that over by the loop counter x9 times the spacing at LSL3, and then we're going to branch to loop. We're going to compare the loop counter x9 with the max index value stored in x8. If they're equal, we go to done. They're equal. We're done. So we're going to retrieve the return address from the stack that we stored right at the beginning of this function, and we're going to adjust that stack. We're going to return to that address at the link register. Now we want to print a header before we show all the sequence values. So we're going to load the address for the variable of the user input into x0. Now we're going to load the data that is located at the address stored in x0. We're going to load that into w1. I'm going to load the format string format for the sequence header into x0, and then we're going to branch to printf. That shows us down here fib sequence values for index 0 to 6, because 6 is the index value we picked. Now we're going to go through our show fib sequence so we can get all these values up on the board here. We're going to show the so I'm going to load the address of the Fibonacci array into x0. I'm going to load the address of the user input variable into x2. I'm going to load the data that's at the address of x2 that's in x2 into w1. Then I'm going to branch to the show fib sequence function. Here we are. We're going to save the return address onto the stack and adjust the stack pointer. We're going to the array address from x0, we're going to move it into x3. The max index, that is our index value that we chose, that's 6. We're going to, it came in x1 register, we're going to move it to x4 register. Now we're going to use x1 as our loop counter, so we're going to put, and we're going to initialize to 0. So we're going to put 0 value into our x1 register, and here we are in the loop. Okay, we're going to compare the loop counter, which is x1, with the max index value, which is x4. If the I used greater than to go to done. So if it's greater than, then we're going to done. Because when I was using equal, it wasn't printing the last value. I'm sure I could have done some other work to adjust that. This works. I'm going to the format string that's going to print each value. I'm going to load that into x0. Now I'm going to assign, I'm actually using x2. I'm going to assign the x2 value into the, I'm loading the value, the fib value from the address at x3, indexed by the loop counter at x1 times the spacing at LSL3, and I'm going to load that into x2. I'm going to save the current index value from x1 onto the stack and adjust the stack. I'm going to save the address of the, I got to save everything before I call printf or I'll lose it. So I'm saving the address of the fib array onto the stack and adjusting the stack. I'm going to save the index value, chosen in x4 onto the stack and adjust. I'm calling printf to print this first value. There it is. Fib 0 equals 0. Now I'm going to retrieve those values I wanted as I said, retrieve x4, that's the index value, max index value. Retrieve the address of the stack from x3 in the stack, and retrieve the current loop counter into x1 from the stack. For all three of those, by the way, I'm adjusting the stack afterwards, obviously. I'll try and remember to mention that. Increment the loop counter, x1 plus 1 goes into x1, and branch to the top again. So we're going to go through this 5 more times. Compare the loop counter from x1 with the max index value at x4. If it's greater than, branch to done. It's not. Load that format string into x0. Now we're going to load that the actual fib value from the array at x3, but spaced with x1, which is the loop counter times the spacing. We load that value into x2. Now we're going to save the current index value. We're going to save x1 onto the stack and adjust. Save x3 onto the stack and adjust. Save x4 onto the stack and adjust. We're going to run that printf. There we go. Fibonacci 1 equals 1. Now retrieve that index value back into x4 and adjust the stack. Retrieve that array address and adjust the stack. Retrieve the loop counter into x1 and adjust the stack. Increment the loop counter by 1, x1 plus 1 into x1, and loop. Now compare the loop counter x1 with the index value, max index value x4. We're going to end the loop if it's greater than. It's not. So loading the format string again into x0. I'm going to try and say this shorter. We're going to load that fib value that we just calculated, all that stuff in fib sequence. We're going to load it out of the address array at x3 by our index spacing using the loop counter. We're going to save the index value into the stack and adjust. Save the x3 into fib array address onto the stack and adjust, and save the max index value x4 onto the stack and adjust. Call that printf. There we go. Fib value of 2 is 1. We're going to retrieve the max index from the stack onto x4 and adjust. Retrieve the fib array from the stack and into x3 and adjust. We're going to retrieve the loop counter into x1 and adjust the stack. We're going to increment loop counter up by 1 and branch to the beginning of the loop. Now we're going to compare the loop counter from x1 with our max index value at x4. If it's greater than, go to done. It's not. We're going to put the format string into x0 again. We're going to pull out that next fib index value at array x3 by loop counter index x1 with the space in VLSL3. Put all that in x2. Now we're going to save the current index value from x1, storing x1 onto the stack pointer and adjust. Storing x3 onto the stack pointer and adjust, storing x4 onto the stack pointer and adjust. Call that printf. There we go. Fib value of 3, index 3 is 2. Now we're going to load that max index back from the stack pointer and adjust. Load that fib array address from the stack and adjust. Retrieve the current loop counter from the stack and adjust. Increment the loop counter by 1. Branch to the beginning of the loop. Compare x1 loop counter with max index value x4. If it's greater than, go to done. It's not. Assign the format string goes into x0. We're going to pull that next fib value, again, loop counter times spacing from our fib index, our fib array at x3. All that value that we pulled goes into x2. We save the current index value, it's our current loop, onto the stack and adjust. save the fib array address onto the stack and x3 on the stack and adjust. Save the max index x4 onto the stack and adjust. Call printf. There we go. Fib 4 equals 3. Now retrieve the fib sequence array limit. Retrieve the max index from the stack and adjust the into x4 and adjust. Retrieve the fib array address from the stack into x3 and adjust. Retrieve the loop counter from the stack into x1 and adjust. Increment the loop counter x1 plus 1 into x1. Branch to loop. Compare loop counter with the max index value. If it's greater than, go to done. It's not. So we format string goes into x0. We extract that current fib value from the fib address, the fib array address, sorry, at x3. It goes into x2. We save the current loop counter onto the stack and adjust. Save the fib array address onto the stack and adjust. Save the max index from x4 onto the stack and adjust. Call the printf. There we go. Fib 5 equals 5. One more to go. Retrieve the fib sequence array. So retrieve the max index from x4 from the stack into x4 and adjust. Retrieve the fib array address from the stack into x3 and adjust. Retrieve the current loop counter from the stack into x1 and adjust. Increment that loop counter by 1. x1 plus 1 into x1. Branch to the beginning of the loop. Compare x1 with x4. If it's greater than, go to done. It's not yet. Load the format string into x0 and extract that last fib value from the array at x3 using the loop counter x1 times the spacing at LSL3 and put that value into x2. We're going to save the current index value, that's the loop counter, from x1 onto the stack pointer and adjust. We're going to save the fib array address from x3 onto the stack pointer and adjust. We're going to save the max index value that we chose in main at the beginning from x4 onto the stack pointer and adjust. We're going to call printf for our last value. Fib of values, or index 6 is a value of 8. We're going to retrieve the fib index. We're going to retrieve that max value from the stack onto x4 and adjust. Retrieve the fib array address onto the stack from the stack into x3 and adjust. Retrieve the current loop counter from the stack into x1 and adjust. We're going to add one more to that loop counter. x1 plus 1 goes into x1. Branch to the beginning of the loop. Now we're going to compare our loop counter x1 with our max index value x4. It is greater than, so we're going to branch to done. There we go. We're going to retrieve that return address from the stack pointer and adjust the stack pointer, and we're going to go to that address stored in link register. Now we're back in main, and we've shown all our values using index 6. We got the dynamic value of 8, recursive value of 8, and from 0 to 6 all the way. We're going to assign 0 to x0 in order to return 0 from the function, so that we return 0 at the end of our main. And we're going to adjust the stack pointer to the same place it was at before returning to the function, and we're going to return from the function. So now I'm going to run. That was our whole loop. You can see here for a value of index value of 6 that we entered right here. I'm going to run. I'm going to debug to main, and I'm going to run one more for you with the value of 20. So we're waiting for the scanf to come up. There it is. I'm going to put in 20. And I'm just going to hit play, and we're going to see all the values come up for 20. Play. There we go. 20. We get the correct using dynamic. We get the correct using recursive. You can see it printed out that I took 20. And then it gives us all the values from 0 to 20. And here they are to confirm. Stopping at the last one. And that's it. Thank you very much. Enjoy.